Let's take a look now at the space vehicles. I think that is an area where we should look at this modeling and simulation technologies for space vehicles in two areas. One, the space station models, but also the airplanes of the future. Both of these models are derived from the basic technology that we have learned in designing ground vehicles. So let's take a look at this technology for space vehicles in these two areas. So the thing is that we have understanding the airplanes of the future. NASA had the morphing project called uh, for studying the changing of wings of the airplanes. And what I'm going to show you is a combination of solid modeling, finite element model, dynamic analysis, and of course, vibration analysis. In this case, you have a couple of technologies that we use. We use something called bond graph modeling, which is the subject of the modeling and simulation class. But we're concentrating right now on the solid modeling of finite element dynamic analysis using multi-bodies and of course continuous media and vibrations. And so we're gonna take a look at the different concepts and ideas here. What about if airplanes would not need an airport as we know it today, as maybe they could stop differently, maybe the wings change, may require different speeds, and we are the idea is that we should consider these factors as we see in airplanes studies, accessibilities, time, whether they're quiet, low emissions, they are quickly, and of course, innovative with new ideas. The idea of the Morphine project mixes several technologies. For example, the idea of adaptive structural morphing technologies means structures that actually change shape. On a ground vehicle, we don't have any shape changing, but on a space vehicle, we could. Some adaptive control technology, of course, materials, smart materials, nanotechnology, optimization, and biologically inspired flight systems. You know, we have a lot to learn from from the birds. Like for example, the seagull is a bird that can actually hover and not basically with very small control of the wings and the wind, they can basically stay in one place. Question, how come airplanes cannot do that? I think that's a very good question. But obviously, we couldn't have a 747 do that. That's also illogical to think we could do that. But a small airplane that could be used for delivery of messages or packages or small airplane that can adjust, make adjustments like that. It might be possible someday that imitating the birds in nature, we or the that matter fish because fish also is in are in fluids or the big mammals or in the ocean also could be possible. So we want structures that are compliant. We want something that either learn from avian or marine wings design maybe tuned to specific condition and dynamic trajectories and biomimic materials. Okay, here's an innovative adaptive structure called morphing structure. This is, if you take a look and reflect on what you can do with the ground vehicle, can you model this in SolidWorks? Chances are that with a little bit of time and patience, you should be able to model this without a problem. In fact, we have done it in this class before. This is a model generated here with the software like SolidWorks and Nastran 4D. So in here, we should look at some previous work that NASA had done on these wings. This was done at the Langley Research Center. And they had this idea, they had like this structure that had connections over here that can actually flex the wing. Yeah. So that is it's called the articulate truss concept of NASA Langley Research Center. This is something from our own, from the California State University. See this idea? This idea comes from a set of mechanisms that can be this is working model 2D, but actually could actually be used if you have a set of cables or articulation like this to be able to change the shape of the wing. Yeah. Or you could have this one with cables, actuators, and things like that. Or you could have this one. So there are different concepts of flexible wings with alternative design. Or you can have this one, a 3D model. Or you see, that could actually change things. This is good. On this, you can see the airplane in different maneuvers here that we can actually control. This was perhaps our early models done here at CSUS, of which I am very proud of you guys, I mean the students who made this. These are people in class like this. And once you put them into Nastran 4D, if you make the wings flexible and you could put forces on the wing to flex them, you can produce a finite element dynamic model like the one here. And that, of course, is because we have the ability in Nastran 4D or SimWise 4D to do dynamic finite elements. And this is another view. These are the possible projects that can be derived from this study. For the modes of vibration, for example, the study of kinematics with variable length truss members, integrating control systems with this, electromechanical and electrohydraulic actuator models, detailed model of sensor dynamics, or evaluation of alternative designs, whether they are for static models or dynamic models. I like this. I saw this quote by Arthur Clarke that says, the only way to discover the limits of the possible is to go beyond into the impossible. Hmm? Very interesting thinking. So this is my end for the presentation of the dynamic into the space vehicles. Now, let's take a look at the space station, okay? This is the space station developed also with the same technology. All right. Here's